Good morning, dear students. In the last class, we discussed about different types of polynomial like linear, quadratic, cubic, all these polynomials. Now here we have one more concept in this polynomial, that is nothing but zeros of polynomial. What is the zero of polynomial? Yeah, the zero of polynomial is defined as any real value of x for which the value of the polynomial become 0. So here a real number k is 0 of polynomial p of x if p of k is equal to 0. So I took an example here to make it to make you more clear. So here p of x is equal to x minus 5. Okay, so I want to make this x minus 5 as 0. So for that I need to give one value for the variable x. So which value make this x minus 5 0? Yes, it is nothing but x is equal to 5. If you take x is equal to 5 and you substitute this x value in the place of x, so you'll get x 5 minus 5 which is equals to 0. So therefore p of x which is equals to 0. Okay, so all the times we're not able to guess the numbers. All that for all the problems we're not able to guess the numbers, and we're not able to write like that. So how to find the zeros then? Yes, here we have a solution for that. So we already discussed about this first case. What is it? P of x is equal to x plus 5. So the value of x is 5, so it makes the entire equation 0. So then what about this case now? And what about this case? So are we able to keep on guessing the numbers and keep on changing the numbers and doing the find the zeros of polynomials? No, it is very difficult. It is but also it's very lengthy too. So to avoid that, we have one method to find the zeros of polynomial. So first see here what type of polynomial it is. It is linear polynomial. Why? Because it of degree 1. So how many zeros you'll get? Suppose if it is a linear polynomial, then it has only one zero. If it is quadratic polynomial, it has two zeros. If it is cubic polynomial, it has three zeros. Okay, then how to find the zeros? Okay, now we'll do one thing. So we want zeros of polynomial. So now what we can do? We can write here 0 which is equals to x plus 5. Now isolate the x term. Then transpose this uh, plus 5 to RHS. What you will get? X is equals to minus 5. So this x is equals to minus 5 is the 0 of the polynomial of p of x. Let's check that. What we'll do now, instead of x we replace by minus 5, then it will become 0 or not, we'll check it. So here p of x which is equals to x plus 5. So then p of minus 5, as substituting x value is minus 5 which is equals to minus 5 plus 5. The same numbers with different sign get cancels and it becomes 0. So therefore p of minus 5 is equal to 0. Therefore minus 5 is the 0 of the polynomial of this p of x. Then we'll check with this. So again the same thing, 0 which is equals to x minus 5. Now isolate the x term. So what you'll get? X is equals to, when it comes to the RHS it become plus 5, isn't? So x is equal to plus 5. Now substitute this x is equal to plus 5 in this p of x. So p of x which is equals to x minus 5. So p of x which is equals to x is 5 minus 5. So what is 5 minus 5? 5 minus 5 is nothing but 0. So therefore p of 5 is the 0 of the polynomial, or x is equal to 5 is the 0 of this polynomial. Now what about this? Here also the same thing. So 2x plus 5 is equal to 0. Now isolate the x term. So you can write here 2x is equals to minus 5. Then x is equals to minus 5 by 2. Yes. Now we got x value. X value is minus 5 by 2. Now what we'll do, substitute this x is equal to minus 5 by 2 in this value, in this p of x. So p of x, which is equals to 2x plus 5. So which is equals to 2 times x value is minus 5 by 2. Substitute the x value minus 5 by 2 here, then plus 5. Then 2 and 2 get cancelled. So then what remains? Minus 5 plus 5, which is equals to 0. Yes, we got the answer, that is p of x is equal to 0. So we got the polynomial 0. By which value you got 0? That is nothing but x is equal to minus 5 by 2. So therefore the 0 of the polynomial of p of x is equal to 2x plus 5 is minus 5 by 2. I hope you understood what do you mean by the 0 of the polynomial. Yes. So here also we have some problems to solve. So here also you can solve that. So here 3x minus 2 is equal to 0. So therefore what is the x value? So here 3x, which is equals to 2. So therefore x is equals to 2 by 3. Okay. So x is equal to 2 by 3. So this x is 2 by 3 is the 0 of the polynomial. Okay. So we want to verify whether what you got is right or wrong. Yes, don't worry. So just substitute the value of x in p of x. So therefore p of x, which is equals to 3x minus 2, so which is equal to 3 times 2 by 3 minus 2. So 3 and 3 get cancelled. So it remains with 2 minus 2. What is 2 minus 2? Is nothing but 0. So we got that p of x is equal to 0 by which value? By which x value? That is nothing but 2 by 3. Therefore 2 by 3 is 0 of polynomial of p of x. 0 of polynomial of 0 of polynomial of p of x. Okay. So now you try with these two problems. Okay. And we'll go for the next type of zeros of polynomial. This is algebraically. What we learned now is algebraically. Now we move to the how to solve the zero of polynomial geometrically. So geometrical meaning of zeros of polynomial. What is this geometrical meaning of zeros of polynomial? You know that a real number k is a zero of polynomial p of x if p of k is equal to 0. But why are the zeros of polynomial so important? To answer this, first we will see the geometrical representation of linear, quadratic polynomials and geometrical meaning of their zeros. Okay, here we have two graphs. One is linear polynomial graph and other is quadratic polynomial graph. So what is this linear polynomial graph? Okay, when we plot, when we see this is y is equals to 2x plus 3 is the linear polynomial. So what is the zero of this polynomial? Okay, we'll solve this. So that is, if we take this is p of x is equals to 2x plus 3. So as we done in the last problem and all, so what we can write here with 0, which is equals to 2x plus 3, right? So what is our x value? So x value is nothing but minus 3, which is equals to 2 by x. So 2 into x, so minus 3 by 2, which is equals to x. So what do you mean by minus 3 by 2? Minus 3 by 2, if you write in the decimal, is nothing but minus 1.5, right? If we divide and if you write that 3 by 2 as a decimal, so you'll get minus 1.5. So our x value is minus 1.5. Just look here where this line intersecting x-axis. It is intersecting at this point, right? So what is that point represent? So here it is 0, here it is 1, and here it is 2. So in between that it is there. It is nothing but 0.5, that is 1.5. So therefore the x value is minus 1.5. From the graph we can say that is what is the value of x. Now look here. So here this is a quadratic polynomial. So this quadratic polynomial, so here y is equals to x square minus 3x minus 4. So from if you find the values of zeros of this, I told you that linear polynomial has 1 zeros, quadratic polynomial has 2 zeros, cubic polynomial has 3 zeros. So here this is a quadratic polynomial. How many zeros it has? Yes, it has 2 zeros. So quadratic polynomial has 2 zeros. Okay, so which are the zeros? By looking into graph, can you tell? Yes, of course. Can we tell using this graph? How it is? It is very simple. So that is, just look into the x-axis, and where this parabola, this is known as parabola, this u-shaped graph, this u-shaped curve is known as parabola, where this parabola meeting the x-axis. Here you may see that this is meeting at this point and also at this point. So what is this point? This point is nothing but -1. And what is this point? This point is nothing but 4. So therefore the zeros of polynomial of y is equals to x square minus 3x minus 4 is -1 and 4. I think it's very simple. Compared to this, it is very simple, right? And even here also you can guess without doing the steps. So just remember that is nothing but the graphically geometrical meaning of zeros of polynomial is very easy, and also examination point of view it is very important for 1 mark. In the examination they may give the graph like this and they ask you to find the zeros of polynomial. So how to find the zeros of polynomial? It is very simple. Just you have to see where the where the graph touching the x-axis. So here it is touching. Is it zeros of polynomial? No. Why? Because this line is y-axis. So only you should concentrate on x-axis. Is it clear? So how many zeros of polynomial this it has? It has only one. It is linear. It has 1 zeros of polynomial. 1 zero of polynomial. And here it is quadratic polynomial. It has 2 zeros of polynomial. What about cubic polynomial? It has 3 zeros. And what is biquadratic? It is 4. It has 4 zeros. Okay, we'll see some more examples of this polynomials.